All right, here's our last video for the lesson. You guys still with me? Hopefully we're trying our best to follow along and pay attention. Now we're going to write a piecewise defined rule from a graph. So kind of setting up this little table is pretty helpful. We are going to find the domain, the slope, the y-intercept of the three segments that we have in this piecewise function. So here's segment A, here's segment B, here's segment C. It is helpful to note that they are all linear functions. Linear functions get graphed in the form y equals mx plus b, so we're going to come back to that in a minute. But let's just go through each part right here. So we're going to first start with a domain. Identifying the domain of segment A. So remember, domain is your x's. It goes from which x value to which x value. Because we're dealing with ordered pairs, we can use those ordered pairs to actually help us out. We are missing an ordered pair. This one down here, if you look at the graph, it's -2, -10. So segment A goes from a -2x all the way to a +1x right there. So we're going from -2 to +1. That -2 has a closed circle, so we're going to say less than or equal to x, and that -1 has an open circle, so we're going to say is less than 1. So segment A has a domain from -2 to +1, where we include the -2, it's included in this domain. The 1 is not included in the domain of segment A. All right, segment B, those ordered pairs are written out for us. We're going from the ordered pair 1, 4 to 5, 8. So if we look at the x's, we're going from 1 to 5. We can see closed circle to closed circle, so those are included. So we're going from 1 is less than or equal to x is less than or equal to 5. All right, segment C, this one over here, what you can't see in your notes or in this graph very well is that actually is an open circle at C. It got covered up by the closed circle of function B. And when you have an overlap like that, where you have, the 5 is part of this domain, the 5 is part of that domain, that 5 actually cannot be part of both domains. So one piece of the graph, one segment will have a closed circle while the other segment will have an open circle. If you notice here, when x equals 1, it's a closed circle up here because the 1 is included in this function, but the 1 is not included in this function. So that's something important to make sure we're aware of. So the domain for segment C goes from 5 to, why don't we go ahead and identify that ordered pair on the end. That looks like it's 8, 8. So we're going from your x is a 5 all the way to x being an 8. So we'll say from 5 to 8, the 5 is not included with segment C, so 5 is less than x, but the 8 with that closed circle is included, so less than or equal to 8. So we have our domain for segments A, B, and C. Let's find the slope of each segment. Because these are linear functions, our rule is going to end up looking like y equals mx plus b, or we'll write the mx plus b part of it. So finding the slope is helpful. So the slope for segment A, those ordered pairs, it goes from -2, 10, -2, -10. Let's make sure we write down the right pair. -2, -10. All the way to 1, -1. So if we find the slope of this, y2 minus y1, so y2, -1 minus a -10 turns into +10, over x2, 1 minus a -2 turns into +2, and we get 9 over 3. So this one has a slope of 3. All right. So segment B, the ordered pairs that are the endpoints of segment B to find that slope, we're going from 1, 4 to 5, 8. So let's find the slope of that. y2 minus y1, 8 minus 4 over x2 minus x1, 5 minus 1. So 8 minus 4 is 4 over 4. We're getting a slope of positive 1. And then our last segment C is going from 5, 8 all the way to 8, 8. So our slope y2 minus y1, 8 minus 8 over x2, 8 minus 5 minus x1. We're getting 0 divided by 3. Do you guys remember what 0 divided by anything is? 0. So this one has a slope of 0. All right, so now what we want to find are the y-intercepts. So if you look at the graph, really the only y-intercept that we can find from the graph is in segment A. See how segment A crosses the y-axis at a negative 4. So our y-intercept for segment A is a negative 4. That's pretty helpful because we have a little bit of work to do on the other ones. Now to find a y-intercept, if you know the slope and one point on the line, you can find a y-intercept. And here's how that's going to work. We're going to use the equation y equals mx plus b. Zoom in, make it a little bit bigger. And we're going to plug in. I'm going to use this first point right here as my x and y, and I'm going to use this as the m. So the y from the ordered pairs of 4, plug in a 4, equals your slope is 1 times your x is a 1 plus b. And if you remember that b is the y-intercept, that's what we want. So now we have an equation where we can solve for b. So we have 4 equals 1 times 1 is 1 plus b. Subtract 1, we get a y-intercept of 3. All right, we can do the same thing for segment C. The reason we're able to do this is because these are linear functions. So we're going to use, because it's a linear function, y equals mx plus b. We have our x and y from the ordered pair, and we have our slope. Our m is 0. So let's plug in an 8 for the y. Our slope is 0 times the x from the ordered pair is 5, and then plus b, the y-intercept. So 8 equals 0 plus 5 is 0 plus b. Well, b plus 0 is just b, so our y-intercept here is 8. Okay. Now the function for each segment, now that you have a slope and a y-intercept, this is pretty easy to write. Y equals, our slope is positive 3, so 3x. Our y-intercept is negative 4 minus 4. All right, our function for segment B, y equals, we want our slope. Slope is 1, so 1x is just x. And then y-intercept is 3, so plus 3. Again, I'm just plugging into y equals mx plus b. Y equals mx plus b. And then segment C, y equals, our slope is 0, so 0x plus our y-intercept is 8. And that 0 times x simplifies away, so you are left with just y equals 8. All right, now let's write the rule. Piecewise function, final answer. F of x equals a big bracket. We have 3 segments. The equation or the function for the first segment, we're just going to pull this 3x minus 4. We don't need the y equals because we already have f of x equals. So this f of x equals represents the y equals. But we do have 3x minus 4. For which domain? We have to write the domain in here. And if you look above on your chart, we have this function from negative 2 all the way to a positive 1. That's the domain for segment A, which was the first thing we found. All right, segment B, the function was x plus 3. And the domain for that is 1 is less than or equal to x is less than or equal to 5. And then we have segment C. Our function was y equals 8, so we have our 8. Because remember, this is our y equals 8. And then the domain for that segment is 5 is less than x, which is less than or equal to 8. So we basically wrote a rule for each segment and included the domain for that segment. And this is what a piecewise defined function looks like when you write it out. from the given graph.